lecture we will be talking about copper silicon phase diagrams. Now, why this copper and silicon phase diagram is important? Because this is the alloy, or this is the combination of metals which are very important in electronic or microelectronic devices. Because copper being a conductor and silicon being a semiconductor, the combination of these two is very significant in microelectronics and related areas. Now, let us come to the material science part of it. Now, when we have a copper and silicon combined system, there are several intermetallic phases formed. So, intermetallic phases, and these are mainly formed in the copper rich side. So, at room temperature, there are three phases formed. One is eta double dash. This is basically eta double prime. This is basically Cu3Si. Then we have epsilon phase, which is Cu15 Si4. And then we have a gamma phase, where we have a Cu5 to Si. So just to remember these, you can see that there are only one silicon atom here, so number of silicon atoms is 3, so we may call it 1 into 3. There are 4 silicon atoms here and 15 copper atoms, so it's into 4 minus 1, so 4 into 4 16 minus 1, and here it is 1 silicon atom and 5 copper atoms, so it's into 4 plus 1. So that's how you can remember the three phases. Now, coming back to this gamma double prime phase, it has basically it is being named double prime because it has two high temperature modifications. One is gamma and the other one is gamma prime. So the one that is found at room temperature is gamma double prime. Now these are the phases found at room temperature. Now we go to higher temperatures. So at high temperatures, again we can find three phases: delta, beta and kappa. Now the crystal phases of delta and beta are still unknown, whereas the kappa has a structure Cu7Si. Now gamma phase, which is a phase at room temperature, when you provide heat to it, it forms into a delta phase and a kappa phase. And if you further increase the temperature, it actually forms delta phase plus beta phase. Now looking into the phase diagram, so it's really temperature, if you put it degree centigrade, and if you put copper concentration here, so concentration of 0.7 to 0.9, basically silicon concentration. So firstly you will obtain the eta, the 7, and the gamma phase. These are at room temperatures. At lower temperatures, at higher temperatures, we actually get here delta phase and here beta phase, and here you get the kappa phase. So this temperature, this one is around 800 degrees C, and this is around 400 degrees C. So this is around 600 degrees C. Composition of silicon 80 0.9. So this is how this copper and silicon phase diagram looks like.